All right, so our second order of business here will be to create relative frequency distributions using the example data that I just had before. So I'm going to start with percent because I think that's the one that is most familiar to people. So here we have relative frequency distributions. And we're going to start with percent. So to calculate a percent to include in a relative frequency distribution, you're going to want to use the following formula. 100 times f over n. And here f is going to refer to the frequency sorry for my scribbling, and n is going to refer to the total number of observations. So you notice these are the same abbreviations that we were using in the tables before, so we have f and n, and now we're just going to be applying them in a formula here. So I'm actually going to rewrite out the frequency distribution for number of arrests. And I'm going to use that to demonstrate a relative frequency distribution with a percent. We have number of arrests, and again, this is from the same data we had in the last example, where we had 0, 1, 2, 3, and 4 arrests, and different numbers of people who had each of those numbers of arrests. So there are 4 people with 0 arrests, 3 people with 1 arrest, 2 people with 2 arrests, 1 person with 3 arrests, and 2 people with 4 arrests. So our total, or n, was equal to 12. So 12 people in the sample total. So again, this is the same frequency distribution that I had written out on the last slide. Now, though, we're going to be adding a relative frequency, or a percent. So in order to add that, we're going to use this little formula here. So to find the percent of people in our sample who had 0 arrests, we're going to plug in our frequency, or f, and our total number, or n, into this formula. And specifically to do that, we're going to say 100 times our frequency of 4 divided by our total number of observations, or n. And if you do this, you can do the math out. You get 100 times 0.33, and that equals 33%. So I'm going to plug in 33% here. And now we can do this for each of the different observations in our frequency table. So each of these different values. So what percentage of people in our sample had 1 arrests? Well, we'll use this formula. And now instead of plugging in 4 for f, we're going to plug in 3 for f. And our n, or total, is going to stay the same. So here we get 3 over 12, that gives us 0.25, and so we have 25% here. And so you can do this for each of the different values in the table, and in each case you're taking the value here, you're taking the value in your frequency column f, and you're plugging it in for your frequency. N stays the same each time because each time we have the same total number of people in the sample overall. So I'm just going to plug in these numbers here, but go a little bit faster. So for 2 arrests, we got 100 times 2 over 12, and that gives us 17%. And note, with each of these, I'm rounding out to just the digit here, no decimal places, and for the purposes of creating a relative frequency distribution, or anytime you're working with a percent, that's usually fine. For 1, we get 100. So again, we've got a frequency of 1 for 3 arrests, so now we're going to do 1 over 12 times 100. It's going to come out to 8%. So 8% of our sample here had 3 arrests. And then this one, we have a frequency of 2 for 4 arrests, which is the same as our frequency for 2 arrests. So it's going to be the same thing of 100 times 2 over 12, and it's going to come out to 17% again. So by plugging in our frequency of 2 here into the formula, we're getting this, which tells us that 17% of the people in our sample were arrested 4 times in the past. And you can also find the total for your percents, and if you do this, it should add up to 100%. Because 100% is including everybody in the sample, so you're accounting for all the different possible numbers of arrests that somebody could have in your sample. So this is an example of a relative frequency distribution, where now in looking at it, you can see the number of different arrests that people had, and you can also see, relative to the number of people in your sample, how common are these numbers of arrests. So the most common number of arrests was 0, so 1/3 of the people in the sample, or 33%, were not arrested at all. The least common number of arrests in our sample was 3, so 8% of the sample was arrested 3 times. And you can see the relative frequencies, they give you similar information to what these sort of exact frequencies gave you, but now it's just expressed in the form of a percent. So you can also do a relative frequency distribution in the form of a proportion, and it'll give you exactly the same kind of information. It's just the format that's a little bit different. So a proportion, instead of being a percent, that's a number from 0 to 100, a proportion is just a number that's from 0 to 1, and it's expressed in the form of a fraction. And we can find the proportion using this formula, which is f over n. So what you can see is that the only difference between a percent and a proportion is that you're not multiplying it times 100 like you do up here. So it's the same information, but just a different format. But I'll just go through and do one of these with a proportion as well. And we usually call the proportion p. So I'm going to rewrite out this frequency distribution one more time here. So 0, 1, 2, 3, and 4 as the possible numbers of arrests that somebody in our sample could have. And then these are the frequencies that go along with them. So 4, 3, 2, 1, and 2. So again, 4 people had 0 arrests, 3 people had 1 arrest, and so on. Now for the proportion, we're going to be using this proportion formula. So to find the proportion of people in our sample who had 0 arrests, we're going to plug in f and n, and our f, or frequency, for 0 arrests is 4. Our n is the same as it was before, so our total, or n, is going to be 12, because we have 12 people in our sample. So we're just going to be doing 4 divided by 12 for f divided by n, and that's going to give us 0.33. So what you see is that we have sort of exactly the same information that we did up here. The only difference is that instead of saying 33%, we're going to say we have a proportion of 0.33. And so if you were to go through and do each of these, you're going to have the exact same formula here. The only difference is you're not multiplying it times 100. So I can fill in the rest of the table here with the same numbers as we had above. The only difference is that we're expressing them now in a proportion. And part of the reason I go through this is that it's useful to be able to move back and forth between a percent and a proportion, because we'll be doing that at different times. So just the thing to keep in mind is that a proportion and a percent give you the exact same information. The only difference is that with a percent, you're expressing it out of 100. So it's basically number of observations you would have out of 100. And this is expressing it out of 1, where we're saying that, as a fraction out of 1, we have 0.33 proportion of our sample having 0 arrests, whereas out of 100, we would have 33 people with 0 arrests. And again, this example here is how to calculate proportion, but you could do the same thing all the way down to get these numbers here. And in general, if I ever ask you to make a relative frequency distribution, you only need to show me one of these because, as I said before, they carry the same information. So you could either calculate the percent or the proportion for your frequency distribution. You would not have to do both. All right, so that's a relative frequency distribution. And with that, I'm going to hop back to the PowerPoint and talk about a couple other versions of frequency distributions.